Listo, cuando gusten.
Good morning, good afternoon, and good night, wherever you are. Welcome, all the assistants, to this third session of the virtual symposiums toward the 2025 International Conference for Mammoths and their relatives. Here we are in Mexico City, hosting through this Seminario, Relaciones, Hombre-Fauna, and today we have a wonderful presenter that very kindly has agreed to give us a talk. Before going ahead, I want to thank you both, all the participants, and also the different INAH entities that have helping us on this in organizing this issue. So I would like to thank the National Coordination of Anthropology, to the head, Dr. Paloma Bonfield, and the capacitation, vinculation, and academic extension from the same coordination, in particular the technology of information head, Salvador Cristóbal Jesús Portilla Martínez, Luis Olaf Ortega Olmos, and Juan Carlos Carrillo Arevalo, who have been helping us to put together this, and also the YouTube presentation. So thank you very much to all of you, and all the organizers. Eduardo, Felisa, also Aguilar has been helping us, and our working places that allow us to do this. Well, today we have, as I mentioned, to a great word, and very kindly has helping us. She's sorry, Miss Pauline Mbete. She's currently a PhD student at the University of Helsinki at the Department of Geosciences and Geography, and her research project is on the Proboscideans, postcranial morphometrics and ecomorphology, and their utility in reconstructed past environments. She holds a bachelor's degree in education and counseling from the Kenya Methodist University, and a master's degree in human evolutionary biology from Turkana University College, a constituent college of Masdin Muliro University of Science and Technology in Kenya. Also has 2 diploma certificates and 2 certificates in technical education and agriculture from Kenya Technical Teachers College and Pwani University, sorry for the pronunciation, respectively. She's presently also working, she has a work at the National Museum of Kenya from the past 15 years as curator, education officer, collection manager, and now she's a research scientist. However, as I mentioned, currently she's in Helsinki, accomplishing his PhD degree. So, well, thank you very much. Sorry, let me introduce also Dr. Adrian Lister. Probably most of you know of Adrian, and I won't talk more today of him. He's very kindly will speak in 3 weeks for this. He will give us the final presentation in this symposium, but he very kindly has agreed to participate in a discussion on Pauline presentation. So thank you, Adrian, for being here, and thank you all of you again, and please, Pauline, you can go ahead.
All right. Thank you very much for that very good introduction about myself. Like as you have heard, I'm from Kenya, and I'm a PhD student at the University of Helsinki. Yeah, today I feel privileged to talk to you about a very important topic, talking about the state of Proboscidean studies in Africa. And I'm also very happy to talk about a background photo of a site in Africa, Kenya to be specific, which is very instrumental in terms of Proboscidean studies in Africa. So this is Lothagam. For those who have never been to a paleontological site, this is how they look like. This is Lothagam. It is very rich in terms of the Proboscidean fossils we have in Kenya, especially. It has two members, which are very important. And this place is very important because it shows has the evolutionary history of Proboscideans, starting from the primitive species to the modern species. So that's why I decided to have this here with me today. So I was very happy to work on the Proboscidean at Lothagam, a review from research which was done by Professor Vincent Maglew. And Lothagam is very important, especially at their park member, because it shows us how it gives us the transition about when the archaic or the primitive species were phased out by the more derived species. So that is a very important place. And if you have never been to Africa, starting your project, this is a very good place to start with. So our discussion today will basically based on many things, but I will briefly talk about what has been done in Africa, and we will also talk briefly about the discoveries found in Africa, and also the researchers which has been involved in this work, which is very important for you to know, and the recent discovery, which has been done by us and a group of other researchers. And I will be talking about that recent discovery in Africa, specifically for Kenya. And then finally, we'll talk about the challenges of Proboscidean studies in Africa. So welcome all. And yeah, let's talk about Proboscidean in Africa. So basically what has been done for Proboscidean in Africa, it's a lot. And topics have been focusing on the evolutionary history and morphological adaptation and interactions of these animals with the early hominids. And this has truly shown or brought significant advancement, particularly in understanding the climatic and dietary influences on Proboscidean evolution. So I know there are so many people who have worked in Africa in terms of researches, but today I will talk a little bit of what I think is significant, or what I think key discovery which has been done in Africa. So the first very important work which has been done in Africa is about the dental evolution in response to climate and diet. And this is a very important work because it touches on how the Proboscideans were adapting to feeding on grasses. And this work was done by my boss, Professor Hugh Asarinen, and also my other senior boss, Professor Hadrian Lister. And from this research, we can clearly know about when the Proboscideans started on feeding on grasses, which is very important. Like I said, in a review of what Vincent Maglew did in Africa, Kenya to be specific, the research there was showing Proboscideans started feeding on grasses around 4.2 million years. But out of this research, it is now clearer that Proboscideans started feeding on grasses about 23 million years ago to 11 million years. We also have another very important research by these important researchers, Professor Lister and also Professor Sarinen. In their paper of 2023, they clearly show us about Proboscidean shifting to abrasive grass diet without even changing their morphology of their teeth. And that was very important. Yeah, because what we learn or what we see other researchers doing or what they have talked about evolution or adaptation of the molar tooth of the elephant, we see it change in size, especially the crown height, which we call it ipsodont index, and also the number of plates. But for this case, that one didn't change, but they shifted to eating grasses, which was unusual. And so much has also been done in terms of evolutionary histories about about Proboscidean. So like this other researcher, Pascal Tessie, they have talked a lot about how Proboscideans are related to each other using different proxies, especially the Gomphotheres, which were once spread in Africa many years. So this also, I can say it's a very important research work which has been done in Africa. And very important also research has been done by so many other people using different proxies. And this one is about the integration of molecular and morphological data. And the reason why this research is very important because it helps us understand the evolutionary relationship within the Proboscidea. And that is very important because for those who are starting in this field, we know where to go to and we know what other people have done. And for importance, it's about a presenter who did a presentation last week, Dimila Monte. He was part of this research. In case you have question about what they did, you can keep in touch and talk to her. Who did this? So we are going to talk about some of the key researchers and their contribution to the field of African Proboscideans. And one of the most important work, which has been used widely, it's about the mesowear analysis. My boss, Professor Juha Saarinen, from the University of Helsinki has tested this method. And this one is about the changes we see in the occlusal view of Proboscidean teeth based on the food these animals were feeding on. So this was very important, and out of the research, we can now confidently see that the high-crowned moat-ridge molars in elephants, especially the Elephantidae, was closely linked to periods of climate drying, particularly over the last 7 million years. So this is very important. And maybe I can talk a little bit about, apart from testing the ipsodonty or the high crown in molar tooth, we also check on things or traits such as the number of plates, because those ones are associated to derivedness as compared to the primitive species, which seem to have fewer plates as compared to what we have, or when we compare the current or the modern elephants. Yeah, and I forgot about, because we are talking about the African elephant, I was supposed to tell you about the species we have. There's a very big difference between the two remaining species in Africa, the African savanna elephant and also the forest savanna elephant. So there is a difference, and the differences we can also talk about that by looking at the occlusal view or the morphological characteristics of the molar tooth. So that one is one of the things we check. And also the enamel thickness. That one is also very critical because the primitive species compared to the modern species, they differ in that. So those are some of the characteristics we check when we are describing elephant and connecting them to the diet they were using during time. So this is a major study which was done in Africa, and yes. And another study is about the phylogenetic studies that was used to integrate the Asian DNA and also the morphological data. And that one also helps researchers and people interested in this field to know about the relatedness of species, especially the Proboscidean, to each other. So this also in Africa was a major or a critical study which we should look at. And again, we have my other boss, Bill Sanders from the Michigan University. For many people, I know you know him through his book of Evolution and Fossil Record in Africa. We can trace the earliest signs of Proboscidean in fossil record up to until modern elephants. This is very critical, and all his years, the way you know him, he has devoted himself in tracking the 60 million years of Afro-Arabian Proboscidean evolution. And from him, or from this book, he recognizes the importance of understanding Proboscidean evolution as they are keystones of African fauna and the oldest continuously surviving African mammals. And that's why it's very important for us all to see how we can protect them, because they are very important. And that is what I'm doing. Yeah. And the last research which I selected is about also, again, talking about taxonomy, evolution, adaptation, and also changing in our environment in Africa over the last millions of years ago. So this was done again by very important researchers called Shoshani of the University of Asmara. So if you have not seen this paper, kindly check for it. And then the most important thing today is to talk about what has been discovered. And that one is about the work I'm doing with my bosses here, Assistant Professor Yu Asarinen, and my other professor, Juka, from the University of Helsinki, and also Dr. Bill Sanders. And I'm also in consultant to my other professor, Professor Hadrian, and my work is about, or our work is about, to identify postcranial differences between Proboscideans, genera, particularly the genera of Elephas, Loxodonta, Mammoth, and Paleoloxodont. Because through this, or for the people working actively in the field, they can use these traits to identify isolated or partial skeleton, which is, according to them, it's very difficult to identify. So this problem of trying to talk about postcranial elements or differentiating this, that one will be solved through our study. So that is what we are doing, and we will have a morphometric criteria for extant and fossil skeleton collection in Africa and Europe. So that is what we are trying to do currently, exploring these postcranial, which are very important in helping us understand or learn about the past environments. So when I talk about a postcranial element, these are the bones which I'm targeting, the long bone, not the scapula, the hinge and the forelimbs. So from the humerus to the carpals, and from the humerus to the carpals, and also from the femur to the tarsus. And something we have noticed or have seen, it's about the differences we have in this species. There's at least this study is very promising. We have started seeing these differences. And one thing which is very clear about the Proboscidean. It's about the carpals. Compared to the tarsals, the carpals are bigger or larger in size as compared to the tarsal. And we are also looking at other features which we can use to isolate these bones from each other, especially for different Proboscidean taxon. So that will be very good. And it will also set a basis for us to help us know how to protect this important species. Because like I said, currently in Africa, we only have 2 remaining species. The forested, the Loxodonta cyclotic, which habitat is at the forest, and also the savanna elephant, which its habitat is at the savanna, the Loxodonta africana. And something of importance which we also need to know about this important species is that the Asian elephant, which we'll be talking about it, which we'll be learning about it next week, migrated from Africa about 2.5 million years. So these are very important things to study. And we are not the first one to do this work. From this paper, you can see elephant foot has evolved. And for us, we have seen differences in sizes, differences in different parts of the elephant bones. And we will be using this to see if this adaptation or these traits can be used to reconstruct the past environment. So we are not the first one, but looking at the postcranial bone at a different aspect, we are the first one to be doing this. And today I'm very happy, humble, to talk about a research we did recently in Turkana at Area 123. We described a very important skeleton, which has been forgotten for many years. Loxodonta, not Loxodonta, this one is the Elephas atavus. And for those who don't know about it, it's a subspecies of Elephas reki, which lived in Africa about 2.3 million to 1.3 million years. So, and it's extinct. And we have this one, and it has been forgotten for many years. So the matrix we did, it confirms truly this one is Elephas atavus. And we are going to talk in the next slides about what we found. First and foremost, it's important we see how the geology of Area 124, Area 123 is. So in terms of age, because we have 2 members, KBS member, which is younger compared to Upper Bulgy member. So the specimen is said to be aged around 2 million years. And in terms of age, by looking at the matrix we did, this specimen or this Elephas atavus is about 40 years of age. And this is how the geology of Cobifora is. In Kenya, it is on the eastern side of Lake Turkana. You can Google and see where it is. And from the map, you can see where Area 123 is. So we did some metrics of the Area 123, Elephas atavus skeleton. And from the PCA analysis, what you see here, these are different elephant species. This is Elephas atavus. This is the Haitian elephant. So it's very clear that the Elephas atavus is closely related to Elephas, to the Haitian elephant in this regard. As compared to, this is Paleoloxodont, and this one is the savanna elephant, Loxodonta africana, and this is the Loxodonta cyclotic. So it's very clear where it is where it belongs and who is more closely related to who. So the Asian elephant or Elephas atavus is more closely related to the Asian elephant. And we did some other measurement like the shoulder height measurement, and this is very truly a big elephant at that age. We measured the body mass, and it was about 10,508 kgs. And in terms of the molar measurements, which is very critical in differentiating different elephant species, we found that the molar, the plates were more. And as I said earlier, one thing we use to differentiate species from the primitive or the oldest, we count the plates. And this is quite a big number in terms of plate. So this one is clearly a characteristic of a derived elephant species. And as we saw it, we talked about being related to Asian elephant than the other African species. So it had 15 plates, and comparing this, the width and the length, this is truly big in size. So it's a derived species. So like we said, ipsodont index, which is calculated by measuring the height, then you divide that one with width and multiply it with the 100. If it's above 100 millimeters, that one straight, it's animal feeding on grasses. And the reason why the ipsodont index, or why the elephant size of the crown increase, you know, there's so many things associated with that. When an animal starts feeding on grasses, there's a problem of mixing grass and grit. That one wears out the tooth. And also the pytolith, the grassy cells in those grasses, they also wear out teeth. That's why that adaptation of eye crown teeth was very important for this species. And again, we talked about the enamel thickness. The thinner the enamel, the characteristics now changes to animal feeding on grasses, and we can see it clearly with this species. And then we did the mesowear analysis, which was done by my boss, and it shows truly this animal was a grass-eating species. In summary, there's a lot we got from that study, and we checked at the skull morphometrics, and truly it was showing that Elephas atavus and the Asian elephant skulls are of similar metrics. And the only thing they differed from Loxodont and Paleoloxodont skull is being by having taller with longer neurocranium, shorter face, and also very narrow rostrum and forehead. So those are the differences we can see when we compare these species. So in metrics like the forelimbs, they were of similar size, except the ulna. The ulna for the Elephas atavus compared to the Asian elephant, the atavus had a longer ulna compared to the other one. And that one is a very important characteristic because it shows in terms of adaptation, this one was well adapted in walking on more open environment as compared to the Asian elephant. So that is what we could see clearly. And from this other chart, you will realize that there is a very important species here, the Deinotherium, which seems to have a longer manus length. And the reason why it is like this, it is because the Deinotherium didn't get adapted to feeding on grasses. but they were living in a grassy environment. So looking for this food, they had to walk for longer distances to get this food. So that's why they are well adapted in moving in such environment, and they have a longer manus as compared to the others. So that is one thing which was very clear about that. So in general, something which has come out clearly, it's about adaptations of habitats of all animals feeding in closed environment. When we check on the limb bones, the closed forest species, these two limbs, especially the manus, are shorter as compared to those species which are living or feeding on open environments. So that is very clear, and we're also going to test on other species to see truly if it confirms that. But for this case, it was like that. So in conclusion, Elephas atavus was of similar relatively bone proportions to Elephas maxima than to Loxodonta africana, although being intermediate in ulnar proportions, suggesting that intermediate locomotory adaptation. So this is what we can say. So it is of similar limb promotion, but more adapted to feeding on grassy environment as compared to the Asian species. That is what we can conclude out of our study we did with these species. So studying all challenges which we face when it comes to Proboscidean studies in Africa, there are so many, but I have a few which we can talk about today to prepare you for like those who are interested in going to Africa, but currently those are challenges which has been sorted out, especially in Kenya. So like this is very critical. That's why we need people to go out. We need to go out and fill these gaps. The fossil gaps, when it comes to Proboscidean studies in Africa, is incomplete. So we need these gaps to be filled. So it has been very difficult to trace the evolutionary histories in details and also understand factors driving diversification and extinction of this animal. So there is a very important thing we also need to go back and do. And when I talked about my master's course, which I did, and I looked at the fossil Proboscidean of the Lothagam, something which needs to be done again, it's about going back and looking at if truly this species, because there was the mixing or living of species of elephants in same environment, both the archaic and also the modern species. So we need to go back and check if truly these animals, if these Proboscidean live hand in hand. So there's a lot which can be done in this field. So prepare to go back and do that. So other challenges, it's on taxonomic complexities about, there's so much debate about classification, about these various extinct species and subspecies. So it is also very important for researchers to, as they are looking or reviewing this, they need to have a clear record. And so these Proboscidean species appropriately, according to the naming and the groups and lineages they belong, because of this problem people are facing. And also collaborations. We need to know what the geologists, what the ecologists, and the geochemistry, what they are doing. This is a part of me when I was in Ethiopia, studying the Proboscidean postcranials at that museum. The place is rich with all what I wanted to look at. But we need to also learn about what the other disciplines they are saying about this, about past environment. So that is very important. Collaboration is very important to us. And last, I think I'm going, okay. And in conservation, we have challenges for this Proboscidean, especially in Africa. And the biggest challenge here is about poaching and encroachment of these habitats for the Proboscideans. So that remains to be a bigger problem. But with this information about why the elephants are very important, that challenge can be cleared. And that's why we are in school to study about this and see how this thing can be solved. And I'm happy that more research is increasingly focusing on conservation strategies. And this is a good sign for the Proboscidean in Africa. And there's also the problem of permits, but that one has been sorted, especially if I can talk about Kenya. We no longer have those issues. Everything now is online. But yeah, I don't know about the other places, but this nowadays is becoming to be not a big issue. Yeah, there are so many other topics we can learn about Africa in relation to other topics, in relation to phylogenetic relationship among Proboscidean taxa. We can also talk about ecological impacts of why the Proboscidean got extinct, and especially the effects of climate change on their habitat, which can be looked at. But with what we are looking at, the postcranial differences, that one also will help to shed light why this is like this and why they were adapted to like such environments. So that one is very important. So there's a lot we can learn about, we can do in Africa in terms of research. This is just some highlights of what can be done. So thank you very much for listening. And thank you for the organizers of this conference, and also to this institution who have truly done a lot in support of my studies. Asante sana.
Thank you very much, Pauline. Wonderful talk. Before giving the voice to Adrian, let me find with Eduardo. It seems that so far we don't have questions. Certainly, I have a question before asking Adrian to discuss about your talk. As from the Mila's talk last week, and also some of the talks that we give in Mexico on mammoths, we always also show much in regard to also human impact in the past with the mammoths. But I guess in Africa, you have a much larger record of that. So probably that's a quite different area that you don't focus at all. But I guess there are a lot of specialists in that regard. Have you done any work on that?
About what? Maybe come again. I didn't hear what you said.
About the human fossil Proboscideans interactions. Is there any findings in regard to Proboscideans bones modified by human and so forth?
Okay, something I can say for sure, her research which has been done in Africa in regards to the interaction between the Proboscidean and the human, it's the archaeologists currently in Kenya have seen them map out these paleontological sites. And like, for example, if we can talk briefly about Area 123, that one now, it's a very critical or very important site because there are some human remains which have been recovered from that site, especially Homo habilis, and more are coming out from that site. So with the research we are doing currently, that is something which will be of interest when it comes to that. Yeah, I didn't check a lot what has been done, but I know there is a study doing mapping of this paleontological site, especially to areas where proboscideans are involved.
Okay, thank you very much, Pauline. Adrian, if you will, could you give us your points of view about what is the status in the studies on proboscideans in Africa?
Thank you very much, Joachim, and thanks very much, Pauline, for that overview. To begin with, I was very interested when you drew attention to the two living species of African elephant, Africana and Cyclotis, which do live in very different habitats, and they have quite different feeding, because Cyclotis is mostly a browser because it's living in forest, and Africana is a graze-dominated big mixed feeder. I had a look at their molars in our collections in London, and I couldn't really see much difference apart from the size, because Cyclotis is much smaller. And I wondered if you had actually yet made any comparisons, maybe with the postcrania or with the teeth. Clearly, the skulls are quite different in morphology. You can see that even by looking at them, or by looking at the head of the living animals. And that was the beginning, really, of the idea of the taxonomic difference, which was confirmed with the molecular data. But I wonder, in terms of the adaptation of the postcrania, which is your particular research interest, whether you've found anything, whether you've looked at that yet.
Okay, thank you for that great question. Yes, we have not much, but for the specimen we looked at, clearly we could see some differences in terms of size. That's why we are doing this research. There's what the research we did, or the metrics we have done already, we have seen there's quite a big difference between the forested and the one which lives on the savanna grassland in Africa. And there's also something we also noticed about regions, extant species, the Proboscidean species at Ethiopia, compared to what we have in Kenya. They're also showing some distinct differences. So we are going to explore this more, and we are optimistic there will be that clear differences. Yeah, it depends with how many specimens you are dealing with. So yeah, true. There's quite a difference currently.
That's great, because that kind of study comparing different living populations, where we know something about the ecology, migrations, and so on, it can be so important in trying to interpret the fossil species as to what their habitats and adaptations were. And just sort of linking that, you kindly mentioned the work which Juha and I published last year about the dental evolution, and the finding that even as far back as the early Miocene, 23 million years ago, we found that some of the early proboscideans were eating grass. And, you know, we could do that because of Juha's meso-wear method, whereas the isotopic method couldn't pick up that they were eating C3 grass. It's still grass eating. And, you know, that leads to the puzzle. These are proboscideans with a low-crowned, gomphothere, crushing type of teeth, not grinding elephant, yet they're managing to eat grass. And our kind of, you know, answer to that was that the high crowns and the high plate counts of the advanced proboscideans are more related to dust on the food than to the abrasive nature of the silica in the grass itself, or anything like that. So that would be interesting in relation to the modern Cyclotis africana question, because, as I said, I couldn't see much difference in the teeth between the browsing and grazing, but it's maybe not so much about the type of plant food. It's more a question of the inorganic grit or soil that they're picking up with their food. And then the other thing I was very interested in was the principal components analysis, where you showed that your new atavus skull, because I think the PCA was based on skull features, as you showed it.
Yes.
Yes. Finding that the atavus skull was closest to an Elephas, modern Elephas skull, right? And not so far, not so close to the Loxodonta or the Africana. That's really interesting because of this debate that's going on now in the light of the molecular data, which suggested that the European Paleoloxodon actually derived from Loxodonta. We always linked it to Elephas on the basis of skull morphology. And in fact, the atavus subspecies of Elephas reci was specifically linked by Maglio and by Bedin to the European Paleoloxodon. And now the molecular data threw that completely up in the air. So it's really interesting that you found that atavus is actually closer to Elephas. And so if the European Paleoloxodon, which clearly derived from an African ancestor, may not be derived from atavus after all, it may come from some deeper root, which if the molecular data is to be believed is closer to the Loxodonta, it's all still, there's a lot more work to be done. But I think what you've done there with the skull PCA is very significant, important addition to that whole debate.
True. That was a very good results we found from this. So yeah, we are looking forward to studying more species and then see if we can get similar or something closer to what we are looking at.
Yes, it would be great.
This was very, very good.
It would be great to include more species in the same PCA analysis. The problem, of course, is that many fossil skulls are distorted, and so you have to be very careful with the measurements and so on. It can only be done on the most complete and best preserved skulls, but there are some. So great.
Yeah, thank you very much. Yeah. And that's why we are looking forward to coming to your museum and look at this, what you have.
We look forward to welcoming you.
Thank you very much.
Absolutely.
And actually, we have a question from Victor Bravo Cuevas. He, besides congratulating Pauline, and in this same regard with Elephas atavus, he says, considering the close relationship of Elephas atavus with Elephas maximus, what biogeographic implication has the presence of that species in Africa?
Yeah, talking about the implication, you see, we are talking about species which are extinct, and the environment during that time was favorable for these species to thrive in well, as compared to now. The Haitian elephant migrated to other habitats, and it is well adapted to those areas. So right now we are looking at that Asian elephant. What are the differences in sizes? What are the adaptation? What are the morphological differences as compared to what we used to have, like the atavus, and now what we have? So that research is currently looking at, what has changed depending on where these animals are currently. So I think there is no impact, because for the specimen at area 123, that specimen, it is there. It is in situ. It is in that environment, and it is like that. And that is what we found. So when I look at the Haitian elephant, now I can clearly tell you about the differences if I compare, like, something like that. Yeah.
I would add to that the questioner asked about the biogeography. And of course, all elephantids outside of Africa came originally from Africa. And the earliest Asian elephants, or Elephas, let's say at least, in the Indian subcontinent, are about 3 million years ago. And Pauline said that her atavus skeleton is about 2 million years old. So that's not so totally different. So if the closeness in the PCA reflects phylogenetic closeness, and of course that is a big if, but if it does, then it means we're looking for a common ancestor between the atavus and the living Asian elephants, something more than 3 million years ago. So that's one of your challenges, I guess, is to find that early true Elephas in Africa.
Thanks, Adrian.
Thank you for that. Thank you.
And one more question, and that's I have that mostly because in Mexico we also consider important to look at the postcranial elements, but unfortunately we don't have that many. We have hundreds of molars or and cranial portions, but postcranial material, there's not that many. Is that the same case in Africa, or you have a fair amount of postcranial elements?
Yeah, thank you for also that question. In Africa, it's very different because if I start with what we have at the National Museums of Kenya, it's a lot. And we also have national parks. And like I talked about the threats we have in Africa, the poaching issue. So many bones are there, well preserved. So I don't have a problem in looking at that on those other, or in Africa. We have those resources in plenty. And for fossil record, we also have a lot, especially for Loxodonta and Aurora. We have a complete skeleton, which I will be looking at. And so we have something to look at in Africa.
Oh, that's wonderful. Yes, certainly in Mexico, unfortunately, we don't have that many. And we have some, but few complete ones. We have some certain portions of the big bones, and most of our findings are random findings based on construction. People are building something and they go into the deposits with mammoths, and there's usually are just pieces of large bones or molars, as mentioned. Adrian, I don't know if you have anything else would you like to mention?
Yeah, I'm good.
Well, I don't know, Eduardo, if we have anything else.
No, ya. Es todo.
Well, since we won't have right now anything else, I guess we can close here the presentation. Again, thank you very much, Pauline, for this wonderful. The recording of the talk will be staying in YouTube, in a YouTube page of the National Coordination of Anthropology, so people start looking at the past talks. At least over 500 people watch it the first day, and we will try to keep a view of how many people visit, so you can have an idea of how many people is visiting. And Adrian, thank you very much for your thoughts on this topic, and certainly we look forward to meet you in 3 weeks for your talk. And thank you very much to all of the people present here. We remind you that next week we will have another interesting talk, that time with our colleague Raman Sukumar from India, talking about the Asian elephant, mostly the present conservation issues. And also we would like to mention that Next week we will start a little later due to an protection, cyber protection training we have all over Mexico next week. It happens September 19 at 11. So we will start at 11:30 next week. Finally, I would like to thank the people that has hosting us all these talks and will host us the next one, the Coordinación Nacional de Antropología, and especially to Salvador Cristóbal Jesus Portilla, to Luis Olaf, he was today here, to Juan Carlos Carrillo, and all the people of YouTube channel. Also, we would like to thanks to our heads at INAH Morelos and Subdirección del Laboratorio for the support of this seminar. And we look forward to see you next week with another interesting topic. Again, thank you very much, Pauline. Thanks, Adrian.
Thank you. Thank you for the invite.
Okay, bye.
Bye.
Bye-bye.